In this video, we are going to do a Bernoulli probabilities example involving finding the probability of having 5 girls. Okay, so the example says that a couple decides to have 8 children. What is the probability of having exactly 5 girls? Now, there should be a question mark. And assume boys and girls are equally likely. Okay, so what makes this Bernoulli is the fact that there's 2 outcomes for each child. Either it's a boy or it's a girl. And in this case, if I write down the probability that we have a girl, that probability is a half. And similarly, the probability of having a boy is also going to be a half because the problem says that they're equally likely. And in this case, we are after the probability of having exactly 5 girls. So we are interested in counting girls specifically. So this is going to represent P, the probability of a success. It's the probability of having a girl. And a failure in this problem is if we have a boy. And in that case, the probability is also at 1/2. And we'll label this with Q. So we want to know the probability of having 5 girls out of 8 children. It's always a good idea in probability questions to label and write down what probability we are after, what we're trying to find. Okay, so to do this, if I use the idea from our previous video, I know that I'm going to need to have 5 girls. So if I think about having 5 girls, I could just write the letter G 5 times, and that would mean I need to have 3 boys. So write B 3 times. So overall, imagine it's like we have 1, 2, 3, 4, 5, 6, 7, 8 slots, and we have to fill 5 of those with a G. And then the remaining are going to get filled with a B. Okay, so what we need to do is we need to first count the number of ways to have 5 girls in these 8 kids. So the different orders that we could have that give us the result of having 5 girls. And each of those results will have the same probability. So we will now multiply by the probability of each outcome. And I'm a little low on room here, so I'll write it down, but then I'll move it up to the top of the page. So the number of ways to have 5 girls and 8 kids is the number of ways, imagining we have these 8 slots, to choose 5 of them to put G in, to put girls in. And that is going to be 8 choose 5, and then multiply by the probability of each outcome. So for each of the G's, the probability is P. So we're going to be multiplying P times P times P times P times P 5 times, which is P to the 5. And then for the boys, the probability is a Q. So we'd be multiplying Q times Q times Q. So that's 3 Q's, so we'd have Q to the 3. So moving this up to the top of the page now. So this exponent, the 5, comes from the fact that this represents the number of successes. And in this problem, the success is if we have a girl, because that's what the problem is asking us to find, the probability of having 5 girls. And the 3, this other exponent, represents the number of failures. And that's always going to be the case in these Bernoulli problems. That's what these exponents are going to represent. All right, so now if we evaluate this, 8 choose 5 ends up being 56. If I plug in for P, let's see, P is 1/2, so we get 1/2 to the 5th. And then if I plug in for Q, we get 1/2, and then this one's going to be raised to the 3rd. So if I simplify, we get 56 on the numerator. On the denominator, I'm going to, so the way I should think about this is like when I have 1/2 to the 5th, this is going to be 1 to the 5th over 2 to the 5th, which is, and 1 to the 5th is 1, and the bottom is 2 to the 5th. So I get the same sort of thing for 1/2 to the 3rd. And when you multiply the 2 to the 5th times 2 to the 3rd, we add the exponents. So you'll get 2 to the 5 plus 3 on the denominator, which is 2 to the 8. Okay. And if we work out what that is, we get 56 over. And then 2 to the 8 ends up being, let's see, I think 256? And then if we divide the top and the bottom by 4, we get 13 on the top. And on the bottom, 256 divided by 4 is 64. And that is our answer. So in the next video, we are going to do another example, but up the difficulty a little bit. And that, to answer our question, we'll need to consider a range of possibilities.